Algebra 2 Honors 4.7 notes. We are going back to transformations of functions, and we're just going to look at x cubed, x to the fourth, x to the fifth, x to the sixth kind of to start with. And these are transformations that you had at the beginning of this year. So it's a good thing to go back and kind of review these. But we're going to apply these to these different degree polynomials. And so you might want to pause and complete the charts for x cubed and x to the fourth. I've already done it for x to the fifth, x to the sixth. And then see if you've got them right. And just use fractions, please. See how you did. Should be negative 1/8, negative 1/64, positive 1/64, and positive 1/8. And for x to the fourth, this should be a positive 1/16. Should be 1 over 256. Positive 1/4 is also 1 over 256. And 1/2 is 1/16. So those are some basic points that you should know on x cubed, x to the fourth, and then also x to the fifth and x to the sixth. And over here, these are transformations that we've seen before. If you have f of x minus h, it's going to go either to the right or to the left. So they show if it's x minus 5, you go 5 units right, versus if it's x plus 2, you're going to go 2 units left. And vertical translation, you have the plus k on the outside. And if it's plus 1, you go up 1 unit. If it's minus 4, you go down 4 units. Now for reflections, these you have to pay a little more close attention to. If you negate the x inside the function, that is a reflection over the y-axis. And in that case, you take the opposite sign of all your x values. However, if you have the negation on the outside of the function, then you are going to reflect the whole thing over the x-axis, and you end up actually changing the signs on the y-coordinates. Again, these are review of transformations we've seen before. And then we have horizontal stretches or shrinks. And when this happens, you see that the a is times the x inside the function. And you end up, these points shrink in towards the y-axis or away. So it is the x value that changes, and you end up multiplying the x values by 1 over a, by the reciprocal of a. So notice that when it's a 2 here, you have a horizontal shrink by a factor of 1/2, and you would multiply all the x values by 1/2. Versus if it's a 1/2 x on the inside, you end up multiplying all the x values by 2. And it actually moves away from the y-axis. Then we have vertical stretch or shrink, but that's different because the a value is on the outside, and you end up multiplying the y values by the factor of a itself. So if it's an 8 on the outside of the function, you actually multiply all y values by 8. If it's a 1/4 on the outside, you multiply all the y values by 1/4. Now, for end behavior on a cubic, we expect as x goes to positive infinity, y goes to negative infinity. And as x goes to positive infinity, y goes to positive infinity. We expect on that x cubed for it to do something like this. That is a function we've had before. Versus if it's x to the fourth, as x goes to positive infinity, y goes to positive infinity. And as x goes, oh, I did this, I'm sorry, up here, this should have been as x goes to negative infinity, sorry. So here, as x goes to negative infinity, I'm going to just start that over again. As x goes to negative infinity, y goes to positive infinity. And as x goes to positive infinity, y still goes to positive infinity when it's a positive 1, x to the fourth. And so the graph of that looks something like this. And then I just want to compare with x to the fifth and x to the sixth, because x to the fifth will also look something like x cubed, and x to the sixth will also look something like x to the fourth. But what are their differences? So I'm going to just take a moment and look at Desmos. And here, if I put in x raised to the third in line 1, and if I go to line 2 and put x raised to the fifth, what I want you to notice is that x to the fifth eventually, that's the blue, goes up faster and goes down faster. So it gets large positive values for y faster than what does x cubed. It's x to the fifth. It's going up more quickly. Same thing as you go to the left. It goes down to negative infinity more quickly, but not in between 0 and 1. Not between 0 and 1. Because when you take a fraction such as 1/2 to the fifth, you get 1 over 32. And that's going to be below if you take 1/2 to the third, which is 1/8. And so x to the fifth stays close. It flattens out more towards 0, 0 than what does x cubed. And sometimes that's important when you're trying to find area between curves in calculus, is to understand for values between -1 and 0 and 0 and 1, which function lies closer to the x-axis, and the higher powered polynomial will in these basic cases. Same thing kind of happens when instead you have x to the fourth versus x to the sixth. X to the sixth is going to go up faster for values of x greater than 1 or less than -1, because it's to the sixth power. But for values between -1 and 1, since you have fractions, that x to the sixth actually stays closer to the x-axis than does x to the fourth for values between -1 and 1. Just interesting to see that those functions change which function's on top versus which one's in bottom according to the value of x. So back to the notes here. Describe the transformations represented by g and then graph h functions. And while you won't see this in the textbook, I want to see a quick table of values. So for x cubed, I'm okay with just the -2, -1, 0, 1, and 2. And you should know for x cubed, so this is the parent function. These are -8, -1, 0, 1, and +8. And so I would like you to graph and dash the parent function. So -1, 1, 0, 0, 1, 1, and then -2, -8, +2. So it does this change in concavity. So it doesn't just go through smoothly at 0, 0, it does a twist. It changes from concave down to concave up. And you should have that noted on x cubed. All right, so there's your x cubed graph. And then right here, describe. And if you have x minus 3 cubed, that's going to move to the right 3 units. And the -1 on the outside is going to move f down 1 unit. So these table of values, right 3 units, you're going to end up adding 3 to the x values. And those will be your new x values. And down 1, you're going to subtract 1 from the y values. So you end up, that -2, -8 goes to 1, -9. And the -1, -1 moves right 3 and down 1. So it's at 2, -2. And then we end up at 3, -1, which was the origin, but now it's right 3 and down 1. So it's 3, -1. And then we have a 4, 0, and a 5, 7. But right at this 3, -1, you need to know that there is that change in concavity, because that's that 0, 0 being moved. So it's concave down to the left and then switches to concave up as we move to the right. Scooped down to the left and scooped up to the right of 3, -1. So you should have some exact points listed in a table on those, applying the transformation. So same thing with x to the fourth. Start with your just basics for negative 2, negative 1, 0, 1, and 2. And we had those up here. So negative 2 to the fourth is going to be your 16. Negative 1 to the fourth is 1. Then we have a 0, a 1, and then a 16. But remember, it flattens out. So at negative 2, it's way off the charts. At negative 1, it's up 1. At 0, it's 0. And at 1, it's 1. And you want it to look like it's flattening out between those 2 points. Except for this is the parent, so I should be dotting it. And then it's going to go way up to 16. So it's going to go pretty quickly up. And so I'm going to draw it like that to show that I know that by the time x is 2, it's off of the graph. And then the negative 1/2 on the outside, the negative is a reflection in the x-axis, which will change all your y values. And then the 1/2 is a vertical shrink by 1/2, which affects all the y values being half of what they were. So what ends up is you end up multiply y values by negative 1/2. And that will take care of both the reflection in the x-axis as well as the vertical shrink. So now for this was the x to the fourth, this is going to be negative 1/2 x to the fourth. If I use the same x values because they were not affected, all the y values are going to be multiplied by negative 1/2. So this will be a negative 8, a negative 1/2, 0, negative 1/2, and negative 8. And so go to graph that. We still are at 0, 0. Negative 1, we're at 1/2. Positive 1, we're at 1/2. At negative 2, we're at negative 8. And at positive 2, we're at negative 8. So it's very close to the x-axis in here. And then it starts going down a little more steeply. And so I've got a table of values. I have specific points that I've transformed. That's what I want to see in your homework. All right, moving to x to the fifth. Again, for x to the fifth, if we just use negative 2, negative 1, 0, 1, and 2 for x, and then x to the fifth. A negative 2 to the fifth is a negative 32. Then we're going to have a negative 1, a 0, a positive 1, and a positive 32. And then over here, the 1/3 being times the x inside is a horizontal stretch by 3. You have to multiply x's by 3. You have to multiply those x's by 3. And then the plus 2 is you're going to go vertically up 2 units. And that means we're going to add 2 to the y coordinates. So under that transformation, we have x and we have this 1/3 x to the fifth plus 2. All the x's are going to be multiplied by 3. So we have a negative 6, a negative 3, a 0, a 3, and a 6. And then we're moving it up vertically 2 units. So this would be at negative 30. This would be at 1. This would be at 2. This will be at 3. And then moving it up to, this would be at 34. So at negative 3, we're up at 1. At 0, we're up at 2. At 3, we're up at 3. And then by the time you hit negative 6, you're going to be off the chart. So this is x to the parent function, which I didn't get graphed in here, I should. The parent function is going to look like this. And so now we've stretched it horizontally. And what I've asked is just that table of values. So what I have is fine. So it's going to come like this. And by the time it hits 6, it's down at negative 30, so it's going to be off the chart before we hit the x value 6. And similarly, before I hit 6 to the right, this is going to be off the chart. So there is your graph of 1/3 x to the 5th plus 2. And so I want the table of values showing where you've transformed those points, and then plot and sketch both dot the parent function and make a solid line on the final graph. So for x cubed, again, -2, -1, 0, 1, 2. We have -8, -1, 0, 1, and 8 for just the parent function. And so very quickly, sketching it, again, there's a change in concavity, so concave down versus concave up. There's my parent function. And then with the 2 on the outside, we have a vertical stretch by a factor of 2. And the negative x on the inside is a reflection in the y-axis. When you negate the x on the inside, that's a reflection in the y-axis, which means you change all the x values signs. You take the opposite. So the vertical stretch by 2, you're going to multiply y by 2. And the reflection in the x-axis, you're going to multiply, it's supposed to be multiply, x by -1. You're going to change the signs. So the table of values, as we transform these particular points, is going to change all the signs on the x's and then multiply the y values by 2. So -16 and -2, a 0, 2, and 16. So at 2, we're off the chart down at -16. At 1, we're at -2. And we're 0, 0. At -1, we're up at +2. And so this function is going all the way up to 16, so it'll be off the chart before it hits 2. And then it comes and it changes from concave up, twists, and changes to concave down. And it's going to go off the graph before we get to 2. And there is part D. So you need to be able to describe what's happening and be able to give tables of values. Even though the textbook doesn't give tables of values, I am in my notes and I want them in your homework. Then you're going to need to write rules for G. Again, we've seen this before. Describe the graph of G as a transformation of F. And so on this first one, here is your F, and they want you for the function G to perform this transformation, which is going to be G is a vertical stretch by a factor of 2 because we have the 2 on the outside. And it is also, we have x minus 3 on the inside, so it's a translation right 3 units. So that is the description that you need. And then they want you to write the rule. And so you have to be careful. You need to double F, do that vertical stretch. And so that's not going to be my final answer. And this was one thing people struggled with because you have to multiply both pieces of F. You have to distribute that 2 across the entire F. So that is going to get you your vertical stretch. So you have to double that 2 as well. Then we are going to do a translation right 3 units. So we're going to replace x with an x minus 3. And that will be my final function. And I'm not expecting you to multiply that out. That right there is a good final answer for that. Excuse me, let's look at part B. So we have F and G is this transformation, which is just a vertical, G is a vertical shrink. By a factor of 1/4. And that means you just need to multiply f of x, all terms of f of x, by 1/4. So that's just one transformation. We can do it all at once. So I would write them with decimals. So we get 5/4 x cubed, and we'll have a minus 1 x squared. 1/4 of 2 is a 1/2 x, and 1/4 of a minus 8 is a minus 2. And there is the rule for G. We also need this box because that is your description. Example 3, write a rule for G that represents the indicated transformations of the graph of f. And we want a vertical stretch by a factor of 3. So I'm going to just start and do this one at a time. And the final graph is going to be called G of x. So I'm going to just use some other variables. A vertical stretch, you need to multiply each part by 3. Then if we apply a translation 2 units to the right, then I'm just going to call it m of x. We need to replace x with x minus 2 to the 5th. And that will move it to the right 2 units. And then a reflection in the y-axis, you replace x with a negative x inside. And that's going to be my final one. So this is g of x, and I'm going to have 3 minus x minus 2 to the 5th plus 12. And I would just leave it like that. I will tell you that a minus x minus 2 to the 5th, I can think of it as a negative 1 times x plus 2 to the 5th, which is a negative 1 to the 5th, x plus 2 to the 5th. And I don't know if in the textbook they might replace that, but I'm not looking for you to do that. I'm good with it just like this. Part B. Horizontal stretch. I just mentioned that before in part A in case you're grading it and you're wondering how did the item minus 3 quantity x plus 2 to the 5th plus 12. I just wanted to mention that. All right, part B. Horizontal stretch by a factor of 2 means you need to find f of 1/2 x. You need to replace all x's with 1/2 x because you have to use the reciprocal for horizontal movements. And so I'm just going to call that h of x. Would be replace x with 1/2 x, and it needs to be the cubed on the outside. You need the parentheses. And 4 then times 1/2 x to the first minus 1, which we'll go ahead and clean up a little bit because that's going to be a 1/8 x cubed plus 2x minus 1. And so there is the horizontal stretch by a factor of 2. Then a translation 3 units down. So I'm just going to call that m of x, and that means we're just going to subtract 3. So that's going to make this a minus 4. And then finally, a reflection in the x-axis. You negate the entire function, so you have to change all the signs. So my final answer, g of x, is a negative 1/8 x cubed minus 2x plus 4. So that's good. And there you have it.